Welcome back to Dirty Barry. Today I've got a nice fun short one for you. So I'm making a whole load of test jig pins for an electronics PCB assembly. So we're making it out of brass hex bar, and we need to flatten off two faces to make it down to 4mm thick as part of the process. So I did a basic lathe turning operation to make it have the round end and the pin end, and we'll place a thread on this end. And then we take it over to the milling machine. So here's where the point of the video is. To remove the mount from the hex to make it into the flat, as shown in here, I've made up a simple 3D printed jig. So this sits in between the jaws of the vise and acts as a parallel. So the first side goes in over here. It sits on top of the lower part of a plastic parallel. We can lop off the top, and then we can take the part out, flip it over, stick it on the higher part of the parallel and lop the rest off without having to adjust the milling machine settings, and they always come out to the exact same size. So I'll show you a quick shot of the turning, and then I'll show you the machining process on the mill. So now we're over at the milling machine. We'll place a parallel underneath the work. We'll take a quick pass, and we'll flip it over, and we're done. So here is a flattened part, if it'll focus. So it's done. Nice and easy, and repeatable. So, there's one change that I probably would make to this, and that would be to put a tab on here, so it can push up against the edge of the vice jaw. That way it's not floating around all the time. But, yeah. So I've got another 30 or so of these to do, but this is a really easy jig to make. It costs 5 minutes of time in CAD to draw it up and 20 minutes to print it out, and it saves a fair bit of screwing around. You don't have to worry about getting thin parallels, you don't have to worry about getting steps of parallels, so you can work on your work or adjusting your milling machine between each cut. It just lets you work. So thank you, I'll see you next time.